So what you're about to see next is me solving a LeetCode problem from my course JavaScript and LeetCode, the interview bootcamp, where we solved the 75 most important LeetCode problems using, of course, JavaScript and a JavaScript testing package called Jest. Anyways, the links to that course are in the description below. I hope you enjoy the video.
Alright, so this video will be dedicated to the pseudocode for LeetCode problem 152 max product. So make sure in the terminal you're CD'd into the course directory, exercises folder, and then run this Jest command. And this is going to fail our test suite. So before continuing with this video, I strongly recommend you do the maximum sub-array problem from earlier on in this array section of the Udemy course, because the way we're going to solve this problem will build upon the dynamic programming we learned from maximum subarray. Alright, with that being said, let's get started. So when I first saw this problem, I thought, oh, I'll just take my maximum subarray code, right? Just paste it in, and since we're doing a max product and not a max sum from maximum subarray, I'll just modify this to be a multiplier instead, and I should pass just fine, right? Well, I saved, and as you can see, half the tests pass and half fail. So how come our modified maximum subarray code is not working? Let's check the test.js file. So if we get an input of -2, 3, and -4, it should return 24 back, right? But instead, my code will return 3. But our code needs to count for negative numbers, because remember that when two negative numbers multiply, it becomes a positive number, and we can have a larger product as a result. And again, the problem states they have to be contiguous, right? Just like maximum subarray. So we need to change our code here to account for negative numbers for a bigger max product. And how are we going to do that? Let's remove the faulty code, and I'm going to explain how we're going to account for negative numbers. Here's the pseudocode. We saw that input of -2, 3, and -4, but we're going to create two DP arrays in parallel. A max till index DP array and a min till index DP array. So min till index will calculate the smallest product leading up to that index, okay? It's like the polar opposite of max till index. And why would we try to calculate the smallest product leading up to a given index? Because again, the more quote, or the larger the negative number, we get a larger positive number if one of the input numbers is negative. Now, we're never going to reference this min till index array when we're trying to return the result, okay? So ignore these for now. When our code's finished, we return the largest value from our max till index array. We just use the DP min till index array to recalculate the maximum product in max till index. But again, we still return the largest value from max till index, which is 24. And so let's see how the min till index DP array becomes useful. Let's say we are on -4, all right, and we're on -4 in the input array, and we're trying to figure out the maximum product right here at the second index of max till index. So in our max till index at index I, so right here, let's say our I is at index 2, math.max is going to be whichever is larger of these three things. So which is larger? -4, -4 times 3, because 3 is the largest product leading up to, right before -4 in here. So which is bigger, -4 or -12? Well, -4 is bigger. All right, which is bigger, -4 or -4 times -6? Because again, we multiply the input number times the smallest product leading up to it. Well, -4 times -6 is bigger than just -4 itself. So you say, oh, it's 24. And the min till index I has the exact same inputs that we provide up here, but now it's at math.min. And again, once we finish filling out the max till index DP array, in which we use the min till index DP array as a reference to calculate these max values, our code returns the largest number in max till index. I hope that made sense. And in the next video, we're going to implement the pseudocode Alright, so let's implement the pseudocode from our previous video. So make sure in the terminal you're still seeding to the course directory, exercises folder, and then run this just command again to run our test suite. They will all fail as expected. And now let's implement that pseudocode. So remember that we create a max DP array and min DP array till the index. So I'll do that. Max till index is equal to an array where the first value is the first input number in the input array, so num0. Then I will do the same thing for min till index. Why is that? Because, well, the maximum product and the smallest product up to index 0, assuming there's only one number in, is the first number itself, right? That's why we set the initial first value to be the first input number. Let's add my semicolons actually. And then to do a minor time complexity optimization, I'll say let max is equal to nums0. This should be familiar to you if you did the maximum subarray problem from before. And now let's iterate through the input array. I'll say for let I is equal to 1, I is less than nums.length, I++, and to make my code easier to read, I'll say const num is equal to nums at index I. And now let's fill out the corresponding max till index at the correct index spot and the correct index spot in min till index. So I will say max till index at index I is equal to whichever is larger, right? The input number itself, the input number times the largest product to the left of it. So that'd be max till index, and this was before it, so we say I minus 1, or the input number, so num times the smallest product to the left of it. Because again, if our input number that we're iterating on is negative, multiplying by the smallest product to the left of it could potentially result in a large number. So I'll say num times min till index, right? The largest or the smallest product, most negative product to the left of it. And remember from the pseudocode that for the correct value at that index spot in the DP min index, it's the same three inputs, but we do math.min instead. So I'll just copy this here and say min till index I is equal to math.min, same three inputs from up here. And now let's update our max variable, which will be accurate, right, because of this setting. I'll say max is equal to whichever is larger, the previous max or whatever is in max till index at index I, right, our max DP array. Once this for loop finishes, our max variable will now be the largest product, even after taking into account negative numbers. Great. So after this for loop, I'll just return max, right? And this should pass our test. Great, they do. Let's make sure our code also passes the LeetCode test. So I'll head on there, paste it in, and we're good to go. So what's the maximum product subarray complexity analysis? Time complexity is O of n, right? We have a for loop, no nesting, and space complexity is also O of n. We created two DP arrays, each the same length as the input, right? Our two dynamic programming arrays are the max till index and min till index, and these arrays are both the same length as the input array. Alright, so that concludes this video.
Hey, it's me again. I hope you found my solution video helpful, and I plan on releasing more free content in the future, and to be notified of that kind of stuff, be sure to hit the like button, subscribe, and that little notification bell icon. I'll see you soon.